Not too long ago, I was out flying one of my quads and I noticed some red channel coloring on the goggles, and I really wasn't that far away. I was kind of disappointed in that actually. So I started thinking about things that I could do to improve the range of quads and airplanes that are using DJI, and I started looking around and I came across this AX2 HD2 set by Lumenier. When I did my homework, I found the antennas in this set were designed by TrueRC. And if you're familiar with my channel, you probably know I use quite a bit of TrueRC equipment. So when I found that out, I thought, yeah, I'm gonna have to take a look at these. So let's get them out of the box and put them on the goggles. Real quick, there are a couple of different color options for the visor material. It's a polycarbonate. In my case, I got the smoke gray, but they also offer an orange tint and a green tint. And as you can hopefully see, the patch antenna is mounted right here underneath the polycarbonate, and it's got the correct RP SMA adapters to go onto the goggles themselves. So those are the patch antennas, and then the stubbies are right here. And we're going to talk a little bit about the technology behind these stubbies because I had a little bit of a talk with TrueRC, and I had a chance to ask Hugo, who designs this system, some questions about how these units compare to the stock units that come with the goggles. Okay, I currently have a BDI digidapter on my goggles, and of course you can't use both at the same time, so most of my flying will be digital, but I'm going to leave the wiring alone. I'm just going to take off the digidapter and replace the digidapter unit, and including the analog receiver, with the setup from Lumenier. So just 2 screws, very simple to do. This one pops out on this side, and one more screw on this side comes out. And that's it for the digidapter. That's how easy that comes apart. And in its place, we'll go to the Lumenier AX2 HD2 setup. So we'll just lay that in its spot right there on the goggles, and we'll drive these 2 screws in back into the same place we just took them out from. A quick little public service announcement. The screws used for the BDI digidapter are 10 millimeters, and the ones that you need for the goggles are 8 millimeters. So if you don't have a little stash of screws, you'll need to get some. So just remember an 8 millimeter screw for the Lumenier visor. Okay, with the visor installed, we'll just remove the stock antennas and we'll set these aside. Okay, the RPSMA connectors are attached on the bottom. The stubbies go right here on the top, and that'll complete the install. Let's talk briefly about specifications. The first thing I want to hit on is that these are 5.8 gigahertz antennas, both the patch and the stubbies. That's important if you also fly a DJI drone, because the drone also supports 2.4 gigahertz. Since these are 5.8 gigahertz only, they're probably not a good choice if you also fly the DJI drone. In my case, I only use the air unit, and those only operate at 5.8 gigahertz. And I did verify with Hugo at TrueRC that when you're bound to an air unit, they're only transmitting on the 5.8 gigahertz frequency. I've seen a lot of kind of chatter on the airwaves out there on the forums that you could potentially damage the transmitter on the goggles if you use a 5.8 gigahertz antenna, and that's simply not true if you're only bound to an air unit, which only utilizes 5.8. So if you're bound to an air unit, you're only going to be transmitting in 5.8. The next thing I want to talk about is gain. These antennas, the patch antennas, give you a gain of 8.4 dBIC. That brought up a question that I had because I looked at the FCC filing to find out what DJI advertised regarding gain on their antennas, and they list a 3.0 dBi gain. So I asked Hugo at TrueRC what the difference is between dBi and dBIC, and the answer was that the C refers to a circular rating, where dBi just refers to isotropic. And I thought, well, wait a minute. Aren't these also circular polarized? And the answer is partially. They only partially emit, they're CP-ish, which means they emit on the horizontal and the vertical axis, but the discrimination is kind of weak because the propagation is a little bit random. Next up are the stubby antennas, and that's where I really started to question gain because these are listed at 1.9 gain. And again, the DJI stock antennas are listed at 3.0. So I asked, why would the stubby antennas be a preferred choice? And the answer is that the TrueRC antennas are nearly 100% efficient. Hugo told me if Lumenier used the same metric as DJI, these antennas would be listed as a 6 dBi gain. So almost twice the gain over the DJI stock dipole antennas. The next thing I want to talk about is beam width. For the stubbies, they're omnidirectional, so the beam width is a 360 degree with the radiation efficiency of 99%. On the patch antennas, I'm going to bring up a little diagram and show you. Now, I don't have this on authority from TrueRC. I'm just making a little bit of speculation, but notice how you've got a patch antenna here and a patch antenna here. Before I did this video, I went out and did a little reading, and it looks like a lot of the patch antennas out there list about 105-degree beam width. But if you take two patch antennas and put them together, and you don't have them exactly on a flat plane, in other words, they're angled out slightly, you do get something that's going to be a little bit north of 150 degrees. And that's what this picture tries to illustrate. The left-hand V is a 76-degree beam width. The right-hand V is a 76-degree beam width. The black spot in the middle shows kind of the null area that you'll get up close when the drone or the antennas in the air are close to you. But you can see the white area out far away. That's covered by about 150 degrees worth of beam width. So that's my estimation. I did not verify this with TrueRC, but based on what I'm seeing for other numbers out there in the market regarding patch antennas, but I think that's what you should expect because the patch antenna has a 76-degree beam width on its own, and you've got two of them on the goggles. Another benefit outside of range to these antennas is the compact form factor. Notice how tightly the RP SMA antenna leads fit onto the goggles and how close these stubbies are to the goggle frame itself. So putting them in a storage bag is actually an easier task over the DJI goggles, which stuck out quite a bit more. So I think for the storage aspect, it's definitely more convenient. The next time I get a chance to fly a quad with the DJI system on it, I'll use this antenna setup and I'll let you know how they do with regard to range and what kind of improvements I see. Hey, if you like this kind of content, make sure you hit the subscribe button and the notification bell below so you know when new videos hit the channel. That's all I've got for today. Take it easy. Hey, if you like the work I do here on RC Video Reviews, please consider joining me on Patreon. For about the price of a cup of coffee, you can help me keep making videos just like this one. If you'd like to help out, there's a link in the description and on your screen.